Hello 3D printing friends! Today on the BV3D channel, we'll get this Voxelab Aquila unboxed, built, and see if we can make it melt some plastic. Stick around and we'll get into it right after this. I'm Brian, and you are watching BV3D. Hi, welcome back. Hey, if you're new here and you're wanting to learn about 3D printing, 3D modeling, and other 3D printing related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, so today we're going to get a look at the Voxelab Aquila. Voxelab is a sub-brand of FlashForge, the company behind, well, the FlashForge line of 3D printers, such as the FlashForge Creator and the FlashForge Adventurer. They're kind of known for fully enclosed box-style 3D printers. Now, Voxelab reached out to me a little while back and offered to send this printer to me to take a look at. So big thanks to Voxelab for sending this over. The Aquila is an inexpensive 3D printer with features rivaling the Ender 3 V2. Now, the Ender 3 V2 sells for about $260 US, but the Aquila sells for about $180. And so based on that, it seems to me that Voxelab is targeting the lower end of the consumer 3D printing market with this entry. The thing I want to find out is, at more than $80 less than the Ender 3 V2, but with very similar specs, how good is it really? How's the build quality? How well does it print? Were corners cut to achieve the cost savings? Well, in order to get to that point, we're going to have to start by getting the stuff out of this box and all laid out on the workbench here. So I'll start with a quick time lapse of the unboxing, and then we can go over all the parts. After that, we'll get the printer put together and see if we can get it to print something. And just a quick reminder, this video has chapter markers, so you can jump around to get to the parts that you're most interested in. But now it's time for the unboxing. Okay, so here are all of the parts from the kit all laid out for us to take a look at. And I'm just going to start at one end of this and work my way across. So to begin with, we have these aluminum extrusions, which will form the Z-axis gantry. We have the Z-axis lead screw, we have the Z-axis stepper motor, we have a US-style power cord, we have the spool holder pieces, we have the screen, we have the screen bracket, we have one of the 4 bed adjustment knobs that came off during shipping, and we'll put that back on when we get to assembling the printer. There's a small coil of red PLA filament. There is the printer base with the attached hot end. There are tools. There is a manual. There are lots of bags of parts, and then all of the rest of this stuff is the X-axis gantry. So we'll go over those parts. There is the X-axis belt, the X-axis belt tensioner, the wheel block for the right side of the printer, the X-axis stepper motor and extruder bracket, the X-axis arm, and the X-axis pulley cover, which includes the X-axis end stop switch. Okay, so that's all of the parts that came. Oh, wait. There were also 2 spools of PLA that came in the bottom of the box. One's red and one's black. So that's kind of nice. 2 full 1 kilogram spools of PLA. Okay, so now that's everything. There's all this stuff plus the 2 spools of PLA. Now there's an issue with the base, and I'm going to get all the rest of this stuff cleared off the workbench, and then we can work on the base. I'll show you that in just a second. Okay, so the workbench is all cleared off, and here's the base of the printer. Let me know if you can tell what's wrong. That's right, the base of this printer is warped. Or, you know, putting a positive spin on it, this printer rocks. So I'm pretty sure I know what happened here. Those 2 1 kilogram spools of PLA aren't normally included with the Aquila. Now, Voxelab wanted to make sure I had something to print with, so they put them in the box with the printer. But to make room in the box, I think they pulled out the packing foam that's usually in the bottom of the box. So the filament was in opposite corners of the box, and the printer base was sitting on top of the filament. So it was only supported on opposite corners. And as it bounced along from truck to ship to truck to jet to van on its way to me, the 3 aluminum extrusions which make up the base of this printer shifted relative to one another, and now I have a twisted printer. And I'm not knocking Voxelabs for their generosity. Including those spools was definitely kind of them. So this is a unique situation that shouldn't ordinarily happen, because I'm pretty sure that ordinarily there's packing foam in the bottom of the box instead of filament boxes. Anyway, that's okay. I have a plan. Also, real quick while we're doing this, I want to go ahead and put that one leveling wheel back on the printer. So let's get that done real quick. It looks like the 40/40 extrusion on this side of the printer is the one that shifted. So I'm reasonably confident that if I loosen the 4 M5 bolts on this side, then I can untwist it and the printer will settle into a nice flat shape. And then I can tighten those bolts again and all will be well. So let's try that and see if it works. So I'm going to loosen the bolts on this side. All right, so now I'm going to twist this in the opposite direction. Ooh, I think we got it. Let me tighten those up. There, now it's good. No permanent damage done by using filament boxes as packing material, and we are ready to get this thing assembled. So it's assembly time. If you are more interested in what happens after it's built, use the chapter markers to skip ahead. Those of you who are still with me, you are awesome. Now the people that skipped ahead are awesome too, but they may not realize it because they skipped off into the future and didn't hear me say it. But we'll catch up with them in a little bit after we get this built, and you can let them know. Okay, so the first thing I want to get a look at is inside the electronics bay. I want to see the high current wiring. And I'm doing this now because it's easier to do with the printer upside down, and turning it upside down is easier before it's all put together. Now in particular, I want to see how Voxelab has terminated the ends of the high current power input and output leads on the main board. So that means the power leads coming into the board, as well as the power output leads for the hot end and the bed. So here we are inside the electronics bay, and I've snipped a couple of zip ties and unplugged the cooling fan that's attached to the cover that I removed to get inside here. I don't see ferrules on the ends of the power leads. Ferrules are little crimp-on connectors that keep the individual strands of the wire corralled. And upon inspection, the high current power leads have the ends tinned with solder. Currently, nearly every printer that I've ever looked at has had tinned wire ends. So it's not uncommon at all, but tinned wire ends, when used with clamping terminals such as these, can loosen over time. Loose connections mean more resistance, and more resistance means more heat, and that causes the connection to get even looser. And over time, this cycle repeats until the connections actually heat up enough to cook the plastic connector housing or the circuit board, or both. So it's a potential fire hazard. If you're interested in learning more about this and about wire ferrules, I've got a video linked up here in the top right corner, and it's also linked down in the description. So I spent about 10 or 15 minutes of quality time with the printer, snipping off the tinned ends of the wires and installing ferrules. Then I replaced the zip ties, closed up the electronics bay, and put the printer back on its feet. And I want to say that I'm pretty impressed with the wire management. The power cables were routed neatly around one side of the bay, and the stepper motor cables around the other. Oh, and something else I want to mention is that there was no hot glue glopped over every single connector on the board. So that was a welcome sight. And while we're talking about the electrical stuff, take a look around the back of the printer and make sure the input voltage selector switch is set correctly for your mains power. For me, that's 115 volts. For others, it may be 230 volts. Just set it for whatever is coming out of your walls, and the printer should be happy with it. So now we need to gather our assembly tools, and that's going to be the hex keys, and these are the nice ones with the ball ends on them that I like, and the double-ended wrench. Notably missing from this printer's toolkit is flush cutters. Second printer in a row that didn't include them, so I'm using a pair that came with another printer, and I'll use these when the time comes. Voxelab, please include flush cutters. These things are supremely useful for snipping zip ties and cutting a point on the end of filament to make it easier to load. Okay, let's get this thing put together, shall we? In this step, we'll attach the Z-axis gantry uprights. For that, we need the two 2040 aluminum extrusions and 4 M5 by 45 bolts to secure them to the base. And of course, we need the printer base. One of the extrusions has the Z-axis limit switch on it, and this one goes on the left side of the printer as seen from the front. Make sure that the extrusion is oriented so that the limit switch's mounting bracket is at the bottom outside edge like this. So let's get this one bolted on first. I'll turn the printer on its side for this and insert a bolt. That'll give me something to aim for with the extrusion. I'll tighten the bolt finger tight, and then I'll add the second bolt. With both of them in place, I can tighten them down all the way. Don't overdo it though, you don't want to strip out the threads. Now I'll do the same for the other 2040 extrusion. One bolt into the extrusion, finger tight. Second bolt into the extrusion, finger tight, then tighten them both down. Up next, the X and E axes. Okay, here are the parts we need for the X and E axis. Now it looks like a lot of parts and kind of is, but we'll break this down into smaller chunks so it's not so overwhelming. We'll start by bolting the X and E axis module to the X axis arm, and so for that we need the following. The X and E axis module, the X axis arm, the Bowden tube coupler, and 2 M5 by 14 bolts. First, screw the Bowden tube coupler into the extruder about finger tight. Then tighten it using the wrench. Next, use 2 M5 by 14 bolts to secure the X and E axis module to the left side of the X axis arm. Note that one face of the arm has places drilled out to accommodate the head of this bolt here. You'll see these drilled out parts on both the left and the right sides, and they're in the same spot on each side, so as long as you have the bolt head resting in the drilled out part, you're good. It can be a little tricky to get this one bolt down into the X and E axis module, and I found it easiest to insert that bolt first and then hold it in place with the hex key. Then I could get it screwed into the X axis arm. Do this finger tight, then insert a bolt into the other hole and get it finger tight too. Ensure that this part of the X and E axis module is parallel with the X axis arm, then tighten the bolts to secure it fully. Next, we'll add the hot end assembly and bolt the wheel block onto the right side of the X axis arm. For this, we need the printer base because it has the X carriage and hot end assembly connected to it by wires. We also need the X axis arm with the X and E module installed, the wheel block, the X axis belt, and 1 M5 by 14 bolt. First, lay the X axis belt in the slot along the top of the X axis arm. The smooth side of the belt should be facing up, and the ends of the belt should hang over the ends of the arm. We're not attaching them to anything just yet. Then slide the X carriage and hot end assembly onto the right side of the X axis arm. The arm should be oriented such that the X and E module is on the left side on the back. The hot end's fan shroud should be on the front of the arm, and the nozzle should be facing down. After that, use 1 M5 by 14 bolt to secure the wheel block on the left side of the X-axis arm on the back. Next, we'll install the X-axis belt tensioner and the X-axis limit switch. For this, we need the printer base and the X-axis assembly so far. We need the X-axis belt tensioner, the X-axis pulley cover and limit switch module, 2 M5x14 bolts, and 2 M4x8 bolts. First, disassemble the X-axis belt tensioner. Loop the right side of the belt around the tensioner's pulley, then reassemble the tensioner. Keep the tensioner loose though. Next, use 2 M5x14 bolts to secure the tensioner to the end of the X-axis arm. Make these finger tight. Note that the M5x14 bolt, which secures the tensioner to the back of the arm, also secures the wheel block. Make sure this part of the wheel block is even with the arm, then tighten the 2 M5x14 bolts to secure the wheel block in place. And don't forget to tighten the M5x14 bolt, which secures the front of the tensioner. Now we'll connect the belt to the X carriage. Each end of the belt has a bit of metal crimped to the end of it. Slide each end into the slot on the underside of the X carriage like so. Make sure that the belt is looped around the X-axis stepper motor's pulley on the left side of the arm. And then secure the X-axis pulley cover and limit switch module to the X and E module on the left side of the arm. The X and E axis is now fully assembled. Next step, install it on the printer. Okay, time to get the X-axis installed onto the printer. And also get the eccentric nuts adjusted on the V-slot wheels so everything moves smoothly. We still don't have the Z-axis stepper motor and lead screw installed, and that's on purpose. If those were in place, it would be difficult to tell if the X-axis was moving smoothly on the Z-axis uprights. Now don't worry, we'll get that installed soon enough. So for this step, we need the printer base with the X-axis assembly attached, the aluminum extrusion, which forms the top of the Z gantry, and 4 M5x25 bolts. First, slide the X-axis arm onto the Z-axis gantry. The wheels should be lined up with the slots. Gently lower the X-axis arm to the bed and use some padding between the bed and the nozzle. That thick sheet of paper that tells you to set the voltage input switch should do fine. Attach the top of the Z-axis gantry with the 4 M5x25 bolts. The top of the extrusion is drilled out a little larger to accommodate the bolt heads. Keep the bolts loose until you have all 4 in, then tighten them down. Raise and lower the X-axis arm to make sure things are moving smoothly. Now is also a great time to make any adjustments to the eccentric nuts. These are the adjustment nuts for the wheels that ride in the slots on the aluminum extrusions. You'll notice that on the X-axis the wheels are arranged in a triangular fashion. In this configuration, the wheel that's all alone on one side has an eccentric nut, and so this is the wheel that can be adjusted. These nuts have an offset hole in the center, and the axles of the wheels go through that hole. So when you turn the nut, you're moving the hole, and therefore the wheel, closer to or further away from the aluminum extrusion. So when we want to adjust the wheel's distance from the extrusion, we turn that nut. Okay, but how do we know if we even need to adjust them? The easiest way to check is to see how easy or difficult it is to turn the wheels by hand without moving the part they're attached to. In other words, if you hold the X carriage still and you can easily turn its wheels and the X carriage isn't trying to move as a result, then they're probably a bit loose. So you'll use the wrench to adjust that third wheel and get it closer to the extrusion. There's no way to know which way to turn the nut because you don't know where in its range of travel it currently is. So just pick a direction and turn it and see if that brought the wheel closer to the extrusion. If it didn't, you can turn it the other direction until it does. So take this opportunity to inspect the wheels and make any necessary adjustments. And don't forget the wheels on the Y carriage. This is the part that the bed is attached to. The Y carriage has 2 adjustable wheels on one side, and you'll adjust those to make sure that the bed isn't wobbly. Coming up next, the Z-axis stepper motor and lead screw. We are nearing the end of the build. Let's get the Z-axis stepper motor and lead screw installed. For this, we'll need the printer base so far, the Z-axis stepper motor, the lead screw, and 2 M4x20 countersunk head bolts. Use the two M4x20 bolts to secure the Z-axis stepper motor to the back left side of the Z-axis gantry. Then, thread the lead screw through the brass nut on the X and E axis module and down to the coupler attached to the stepper motor. Loosen the top set screw on the coupler. Finish feeding the lead screw into the coupler. Then, tighten the upper set screw. And as long as we're here, let's make sure the lower set screw is tight too. Okay, we're done with that. On to the next. Let's get the screen installed and then we can connect the wiring. For this, we need the printer so far, the screen bracket, and the screen. Loosen the bolts and the T-nuts on the screen bracket. Then secure the bracket to the right side of the printer at the front. Next, plug the ribbon cable into the back of the screen and snap the screen onto the bracket. The stepper motor and in-stop switch cables are all labeled, so the connections will be easy to make. Plug in the Z-axis stepper motor. Plug in the Z-axis limit switch. Plug in the extruder stepper motor. Plug in the X-axis stepper motor. Plug in the X-axis limit switch. Oh, and plug the Bowden tube into the coupler on the extruder assembly. And that's it for the screen and the wiring. Now let's get the spool holder installed and then we'll be just about ready to adjust the bed, load some filament, and try printing something. For this, we'll need the printer so far, the two spool holder pieces, the two 2020 extrusion end caps, two M4x6 bolts, and two T-nuts. First, remove the nut from the spool holder tube, insert the tube into the bracket, and tighten the nut to secure it. Then insert the M4x6 bolts into the bottom of the spool holder assembly and add the T-nuts. These go on loosely. When we tighten the bolts, the nuts rotate 90 degrees to grab onto the extrusion. So position the spool holder at the top of the Z-axis gantry with the tube facing the back. Tighten the two M4x6 bolts to secure the spool holder. Finally, add the two 2020 end caps to the left and right sides of the top of the Z-axis gantry. Oh, and don't forget to make sure the X and Y belts are tightened. Just turn those adjuster knobs to take the slack out and get them to twang a little bit. And with that, the printer is built. Congratulations! Okay, with the printer built, we probably ought to make sure it'll power on. So double check your voltage selector switch, plug the printer in, and turn it on. On the screen, you should see the Voxelab logo and then the main screen. If so, you've done an awesome job. But we can't start printing just yet. First, we need to get the bed adjusted. There are those who call this operation leveling. And that term has nothing to do with making the bed level with the earth. It has everything to do with making sure that when the nozzle is homed, the bed is at roughly the same level as the nozzle at every X and Y coordinate. And while some manually leveled 3D printers include an assisted leveling function in which the printer moves the nozzle to each corner of the bed so you can adjust it, most don't. The Aquila is in the "it doesn't do that" category. And I'm not a fan of the home the printer, disable the stepper motors, and move the nozzle around the bed yourself process. Fortunately, my friend Peter Solomon has a handy G-code file that does all the moving for you, and all you have to do is adjust the knobs. It's for an Ender 3 series printer, but since the Aquila has the same bed size as the Ender 3, we can use it. Now he's actually got files for a few different printers, and I've got a link to the files in the description. But before we can perform the leveling operation, the bed needs to be at operating temperature. And before we can heat the bed, we need to remove the protective film covering it. Now, I've had comments on other videos asking if the film needs to be removed because it never gets mentioned on build videos. So yes, the film needs to be removed, and now it's done. And I gotta admit, removing it has a certain appeal. Okay, let's lower the bed by turning the adjustment wheels counterclockwise until the springs are pretty well compressed. And then let's heat the bed. Now, if you're wondering why we're doing that, it's because things expand when they heat up and we need the bed at its actual operating temperature and therefore size when we make these adjustments. From the home screen, select Setting, then Temperature. Then set the bed temperature to 60 degrees Celsius. The printer should report that the bed's at temperature after about 2 minutes or so, but let it sit for 5 to give the glass a chance to catch up to the aluminum. Then, from the home screen, select Control and then Auto Home. The printer will home the nozzle. Look at where the nozzle is relative to the bed. We want the nozzle about 1 millimeter or 2 above the bed at this point. So if it looks higher than that, you might need to lower the Z end-stop switch a little bit. To do that, loosen the 2 screws holding the switch on the left Z upright, move the switch down 1 millimeter or 2, and tighten the screws. Then home the printer again, and the nozzle should be closer to the bed. Now this one's looking okay though, so we're good. So with the bed hot and Peter Solomon's assisted leveling G-code on the card and the card in the printer, get a piece of paper, select Print, and then select the file. The printer homes the nozzle again. Then it moves the nozzle over each adjustment knob and waits a few seconds while you turn the knob to bring the bed and nozzle close enough together that you can feel a little friction on the paper when you move it between them. It goes to each corner, then to the center, and repeats like 4 times. Each time around it waits a little less before moving to the next point. When it's done, you should have about the same amount of friction on the paper at each point. If not, that's okay. You can run the file as many times as you need. But I'm happy with the way this one's feeling, so I'm calling it good. Now we can fine-tune it during a print if we need to. Next, we'll load some filament and print a test file. Okay, it's time to load some filament. I'm not going to use that little bitty sample coil of PLA that came with the printer. I'm going to use that spool of red filament that Voxelab sent. They sent both black and red, and I think the red will show up better against the bed. So I like to do 2 things to the end of the filament before loading it. 1, I kind of straighten it out by bending it in the opposite direction of its curve, and 2, I cut a 45-degree angle on it. And cutting that angle is one of those times where flush cutters come in handy. I'm still shocked when printers don't come with them. One thing to keep in mind when handling filament is never leave the end of the filament unsecured. Most spools have holes around the rim so you can tuck the end of it in. So if you're holding it, don't let go of it until you've got it either tucked in or loaded in the printer. Otherwise, it can unwind like a clock spring and then it can get tangled. And you may not notice until you're halfway through a print and suddenly the filament gets stuck under another loop and it won't feed anymore. So here's how to load filament on the Voxelab Aquila. Raise the Z-axis about 100 millimeters up or so to give the filament plenty of room to come out of the nozzle. From the home screen, that's in Control, Move, and Move Z. Now, usually the way I load filament is to heat the nozzle up to working temperature, press the loading arm on the extruder, and just push filament in through the Bowden tube until it starts coming out of the nozzle. Now, although the Aquila doesn't have an assisted leveling feature, it does have a filament loading and unloading feature, so I want to use that. On the screen, that's in Control, then Automatic Load. When we select that, it displays a nice visual to show you what to do. Now, while the printer heats the nozzle up, I'll press the loading arm here and push the filament in until it's just inside the Bowden tube. Then when the nozzle is up to temperature, the filament starts feeding through the tube. The screen tells you it'll take a minute or 2 for the filament to work its way down the tube. Once it does finally get to the nozzle, the printer will keep feeding it in to purge out whatever other filament color may have been loaded previously. Then it stops and the screen goes back to the main page. Okay, the filament's loaded, so let's print something. On the screen, I'll go to Print, and there's an Aquila test model, so I want to print that. And here we go. Okay, I'll leave a time lapse of the print going because time lapses are cool. And while that's running, I want to go over the printer's specs. I've been so busy putting it together, I haven't gotten to that part yet. So it's got a build volume of 220 millimeters on the x-axis, 220 millimeters on the y-axis, and 250 millimeters on the z-axis. It has a Bowden drive extrusion system with a 0.4 millimeter nozzle on a PTFE-lined hot end. It has a 32-bit mainboard with silent stepper drivers. It has power loss recovery, which allows it to resume printing after a power outage. It has an ultra-base style glass bed. It has a color screen with a rotary knob. It has a frame made of aluminum extrusions. It has its power supply tucked away in the back of the printer. It has belt tensioners on the X and Y axes. And at $180 US, it's a heck of a bargain. So here's what I like and what I don't like about it. I like having the screen in landscape mode, and I kind of like that black, red, and white color scheme that Voxelab is using in the user interface. It's laid out pretty intuitively, and after exploring for a few minutes, I knew where most of the commands were. But one thing I've noticed about that knob, though, is that sometimes it's a little twitchy. Sometimes it doesn't click at all when you press it, and sometimes it clicks 2 or 3 times. So that detracts from the usability a little bit. I like the manual, the illustrations are good, and the English is pretty good too, but there are 1 or 2 things that are weirdly translated. The Z-axis lead screw is identified as a T-shaped screw rod, for example, but these are few and far between, and their English is way better than my Chinese. And taking a quick peek at the finished print, the printing quality is pretty darn good too. This little test print takes about an hour or so to print, and it's got a variety of shapes on it. That arch in the center is a good test of overhangs, and it looks like the Aquila did a pretty good job there, with 1 or 2 little loops hanging down at the very top of the underside of the arch. The tetrahedron, that pyramid-like structure, came out pretty good, and even the tip of it is well formed. The other shapes are good too, and looking at the underside of it all, the first layer came out good as well. The bed let go of the print once it had cooled down to room temperature, which is what it's supposed to do. I didn't need to scrape or pry to get it released. And thanks to the silent stepper motor drivers, the printer's movements are pretty quiet. But those fans, they don't do so well in the quiet department. Now the overall unboxing, building, and first print experience is very much like that of the Ender 3 V2. In fact, it's very difficult not to compare the 2 printers because the Aquila is so astonishingly similar to the Ender 3 V2. So what does the Ender 3 V2 have that the Aquila doesn't? Well, it has a knob on the extruder stepper motor, and it has a built-in tool storage drawer, and that's pretty much it. Literally everything else about the Aquila is exactly the same as the Ender 3 V2. Same loud power supply and hot end fans. Same frame design, same assembly process. I mean, I could have just as easily reused the build footage from my Ender 3 V2 unbox build and first print video. I mean, sure, the screen is laid out in landscape orientation instead of portrait, but the panel is optimized for landscape viewing anyway, so that's a win. But the Aquila is $80 less than the Ender 3 V2. So how did Voxelab do that? One of the things keeping the cost down is the fact that the X-axis arm is a DIY project instead of being factory assembled. I've seen some budget printers where the X-axis was already assembled for you, but that means somebody at the factory had to do the putting together job, and that increases the cost. And besides, the Ender 3 V2, you have to build the X-axis arm yourself too. Now I thought maybe it was because the Ender 3 V2 uses a 350 watt mean well power supply, but then I removed the rear cover on the Aquila, and it has a 350 watt mean well power supply too. Now the Aquila didn't have ferrules on the high current wiring on the mainboard, but neither does the Ender 3 V2. And apart from the lack of ferrules and the twitchy clicker on the knob, the quality of the materials and workmanship seems to be good. And that wobbly base at the beginning of the video, that was a result of some extras that Voxelab put in the box at the cost of padding. I don't see that as a material or workmanship issue, plus it was easy enough to fix. But the Ender 3 V2 comes with flush cutters. Did Voxelab really manage to snip that much from the cost of the printer by not including flush cutters? I doubt it. But I really don't know how Voxelab is able to sell this thing for what they're selling it for. And while it's too early for me to tell how well it'll hold up, my initial impression is that you get a lot of printer for not a lot of money. A big thanks again to Voxelab for sending this over so we could get a look at it. Links are in the description if you want to check it out. Well, 3D printing friends, that's about all the time we have for this episode. And now that we're at the end, let's go print something cool. Hey, real quick before you go, I wanted to say thanks for being one of the super awesome people who sticks around all the way to the end, and thanks for all the likes, comments, and shares. And an especially big thanks to those who directly support what I do. You're all wonderful for doing that, and I really appreciate it. If you like this episode, a thumbs up would be great, and if you'd like to help support the channel, check the description for ways you can do exactly that. And hey, if you haven't already subscribed, please do. It's absolutely free, and it's an excellent way to help keep me making these videos for you. Well, that's it for this one. Thanks again, and I'll see you next time here on the BV3D channel.